Hello, my name is Keegan Haar, and this is my session 7 assignment. So, final assignment for this semester. I'll go right into it. Here we have it. We've got our ticket to ride and our city distances text file. So I'll just quickly, show you the text file. Just took what was ever given to us in the rubric there. Then our ticket to ride, which that title's mentioned in the rubric as well. Um, Basically, we got our weighted graph here, obviously our imports and all that. Our weighted graph where we're adding edges and stuff, pretty similar to kind of what we deal with in the final a bit. Um, and obviously, our approach to this is MST, minimum spanning tree. That's how at the end we're going to show the quickest path we can take from a certain city to another designated city. So basically, this is just where we're putting a lot of functionality in for our MST, dealing with edges and all of that. And yeah, stuff we've dealt with obviously in the past already, with a data structure of a MST. Um, So that's that bunch of logic for our MST. I'm not going to get too into detail of it, obviously, just because there's a lot that goes into it. Um, and I really just want to get down to the functionality, which is the biggest part, showing you that it works. Anywho, again, dealing with edges, blah, blah, blah. Then we've got our main class. This is where we're actually calling all of the functionality. So, loading up the file here. Then we're displaying the cities, which is reading them from a file and putting them into an array list, from here. These are our cities, which is being displayed here at the bottom, which I'll show you real soon. I won't get into that in a second. Blah, 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 showing our option for first, second input, which is which cities we're looking to be matched against each other, and then printing out our MST pathing, which is looking for the quickest possible way to get from one city to another. As each city, as you can see in the rubric, has numbers associated with them, which is like distance traveled between the two cities. So the lower the better in this situation. And then loading our file here using regex and all that. So pretty, standard stuff overall. Just a bunch of functionality for the MST up here in the beginning and edges and stuff to help kind of create our boundaries here. And then calling in all the functionality and creating some boundaries for our load file as well, obviously, because a big part of this project is simply just taking all of the stuff from this file and making it make sense to the program. Anywho, I'll be quick here. I'll show you a first test here. You'll see all 18 or 19 cities pop up, my name, certify that this is my work. All of our cities pop up here, and then we'll say we want to compare 6, which is Albuquerque, to 9, which is San Francisco. What's the quickest way we can get there? We can go Albuquerque, Denver, Salt Lake City, and then Salt Lake City. We'll arrive at, and we will only have a cost of 5 right there. Then I will show you another example here. We'll do 5, which is Calgary, and we'll do 17, which is Dallas. So we'll go Calgary, Helena, Salt Lake City, Denver, Albuquerque, and then we'll end up in Albuquerque. So it costs us 7. So that's the functionality of my program. Obviously, it works at the end of the day, and we efficiently use MST to display the final product at the end there. So that is my program overall. Thank you very much.